Over 1.4 billion people live on the Indian subcontinent, sustained by a massive agricultural network that spans the entire region. This high productivity relies on two natural forces: the intense summer monsoons and the sprawling network of rivers that feed the plains. Both of these life-giving forces originate from a single geological feature bordering the north, the Himalayas. To understand how this works, we can try a thought experiment. What would happen to the subcontinent if you erased the Himalayas from the map? The monsoon cycle would likely collapse, and the Ganges and Yamuna rivers would eventually lose their steady supply of water. In this scenario, the subcontinent becomes an arid, high-altitude desert. The Himalayas are an active geological system that makes the region habitable for over 1 billion people. One primary function of the Himalayas is acting as a physical windbreaker for the entire country. It protects the land from katabatic winds, brutal, freezing air masses that sink down from high altitudes across the Tibetan Plateau and Central Asia. This diagram shows how the continuous vertical wall of the Himalayas, rising over 8,000 meters, presents an impenetrable barrier to these weather systems. The air currents are forced upward and dispersed to the east and west, preventing them from crossing the peaks. This deflection is why India remains significantly warmer than other regions at the same latitude. This global visualization shows temperature data along India's specific latitude line, revealing a thermal contrast between the protected subcontinent and the colder, unprotected regions on the same axis. India's hospitable climate is maintained by the physical presence of this rock shield. The mountain range also serves as a moisture trap for the region. During the summer, warm, moisture-heavy air moves north from the Indian Ocean, across the landmass. This diagram illustrates the orographic effect, the process of air being forced upward by rising terrain. As air hits the mountains, the terrain forces the warm mass upward into the freezing upper atmosphere. This causes clouds to rapidly condense and dump their moisture over India. The mountain range triggers the monsoon, forcing clouds to release their moisture strictly within the subcontinent's borders. Finally, these mountains operate as a high-altitude water reservoir. In the extreme heights of the Greater Himalayas, massive amounts of winter snow and ice are trapped in permanent glaciers. This water storage is vital during the dry summer months before the monsoon begins. As temperatures on the plains rise, these glaciers slowly melt, acting like a timed release valve for the region's water supply. This meltwater ensures that the Ganges, Yamuna, and Brahmaputra rivers continue flowing during the driest parts of the year. Without this storage system, India's primary water sources would run dry during the peak of the agricultural season. This interconnected system of protection and water storage supports the entire region. However, climate change is melting the Himalayan ice cap at unprecedented speeds. If it disappears, the water supply for hundreds of millions could vanish. The Himalayas are a vulnerable geological system that regulates the survival of over 1 billion people every day.